We have a manufacturer of microprocessors, and they estimate that T months from now it will sell X thousand units of its main line of microprocessors per month, where X equals this given equation. So here's our X. Because of economies of scale, the profit P for manufacturing and selling it is estimated to be this equation in millions of dollars. Calculate the rate at which profit will be increasing 5 months from now. So we want to find the rate at which profit is increasing. So that means we want to differentiate profit. And we want it in terms of T because we're asking T months from now. So I want to find the rate of dP dt, okay? Because profit and time. Right now I have two separate equations. I'm going to put them together because you can see here this X goes in right here. And I'm going to put it into the P because I want to differentiate that P. But then that's going to give me P of T. So then my P of T becomes 0.001 and then 0.05 T squared plus 2T plus 5 squared plus 0.01 0.05 T squared plus 2T plus 5 minus 0.25. So now this is the profit equation I want to differentiate. At this point, you have a decision to make, and that's how much algebra do you feel like doing? I don't mind this algebra, and I'm going to do this algebra. I don't want to do this. I don't want to multiply those two terms. That's not even FOIL. That's long multiplication. That looks yuck. But our new chain rule means we don't have to. I didn't even have to do the second part, actually, if I don't want to. I'm just choosing, this is where, again, you choose your battles. Which one do I think is easier? I think this algebra is easier than the chain rule would be because the middle is going to go away and I'm still going to integrate it. I'm like, I might get myself confused. So I'm going to choose to differentiate. And usually if it's only a 1 like this one, I will always differentiate. 2 or higher though, especially higher, ugh, anything higher. 2, it depends. If it's a really easy FOIL, I might choose to do it. So I'm going to do that. I'm going to leave this first one as is. And so all I'm doing is copying all this down. And then here I'm going to multiply. So I'm going to do 0.05 times 0.01, which should give me an extra 0. So I should have a bunch of zeros. So, okay. I'm like, I know how many I have, and then I put it in my calculator to double check, and then I'm like, that's wrong. And then I realized I put it into my calculator wrong. So make sure you put it in your calculator right. I'm like, I know that I should have 2 zeros, and it didn't agree with me. And I'm like, okay, this is when, you just got to remember you're smarter than your calculator. Okay, so what I did is I didn't do that first one because I decided that that was evil, but I did do the second one because I decided that was the least amount of work. Now at this point, I'm going to choose to redo this. This is just plus 0.25 now. I'd probably have done that as I did it. I'm not going to rewrite the whole thing. You can if you want. It just kind of depends on what you decide you want to do. I'm also going to be honest. I know that once I take the derivative here in a second, that's going to go away, so I'm not too worried about my constant. And again, those are little things that as you work out, you'll decide kind of where you can save your time and where you can't. Now I'm going to take this derivative. So P of T. So I'm going to bring this 2 down. Okay. I'm going to do 0.002. And then I'm going to keep the middle as is. Subtract 1. So that means this is a 1 up here. And then I'm going to take the derivative of the inside. So I'm going to do 0.05 times 2, which should give me 0.1 T plus 2. And then the 5 is a constant. It goes away. Then I'm going to do the next part. My 0.005 times 2 gives me 0.01 T. And again, that's a 1 plus 0.2. So this is my derivative. Now this is again where I get to make some decisions. What am I doing with this? Well, I found the derivative. I found this that I want. This wants me to put 5 into it. I can put 5 into it there. So then I don't, again, have to do all this distribution, all this algebra. If it asked me for an equation, I would probably do it all because I want the cleanest equation because then I don't know what I'm doing with that equation down the line. So that's when I would do that. But in this case, when all it asks me to do is this, I'm not going to spend any time cleaning that up. I'm just going to put in, so this is 0.05 times 25 plus 10 plus 5 times zero point 0.5 plus 2 plus 0.05 0.2. Okay, now I got to get out the calculator and I got to do this. And so let's see here. What do I got here? Something. See if I can scooch this. There it is. Then I can see all the parts. I'm going to start in here. And so I'm going to do 0.05 times 25 plus 15 times my 0.002 out front times 0.25. Remember order of operations, make sure you're doing it in the right order. And then I'm going to add 0.25, which is just the sum of those two. And I get 0.33125 million. Now, that's probably a hard number. If I was at a board meeting trying to sell it, that's a hard number. 33125 of a million. I'd probably times it by a million and tell them instead that I'm going to make $331,250 a month. That's how much we can expect to be making on our microprocessors 5 months from now in profit. So this is the profit 5 months from now on the microprocessors. That's what we found out. That's the rate. You can come up here and go look. So this is at what rate will profit be increasing? That's my increase in profit per month that I can expect 5 months out as they're building. And so if I wanted to, I'm going to come back here and do a little bit more work just to show you how would I clean this up. Well, at this point, this is just, I would multiply these two, and then I'd multiply that product plus this, then I'd combine all my like terms. It's not awful, but it's definitely a fair bit of algebra. If you were asked for the equation, again, you'd probably want to do that. If you're not, it's just as easy to put the number into there. Now, I will say, if you're someone who knows you have a lot of trouble getting that number in and getting the order of operations in right, you might decide that it's worth doing the multiplication so that you put the 5 in right. So you just, again, it's a decision point. What do I think is the least amount of work for me? And what's the least amount of work for me is not necessarily the least amount of work for you. It's the same with the chain rule. You might decide I would rather have done that multiplication in, with the original equation than do the chain rule. And that's okay. But this is a good example of where that chain rule can really save us some really, I'm going to go with tedious algebra. And I think that that's what we're trying, anytime we can do that, that's usually beneficial because that tedious algebra is where mistakes happen.